Hi everyone. So the goal of this video is to look at position time graphs. Now this is an advanced topic for one of our learning objectives, but for anyone who's shooting for an A and really wants to better understand position time graphs, this is what the video is for. I want you to be able to interpret the slope of a position time graph, and then can you create a velocity time graph given a position time graph? So let's start off with something that I've already talked about, just to recap the basics. We've talked about what a graph shows you. When you look at a position time graph, at any time, it tells you the position of the object. For example, at time equals 0, the position is 0. At time equals 1, the position is 5. At time equals 2, the position is 10. The other thing that we talked about was when the line is going up like this and it has a positive slope, that means the object is moving in the positive direction. So we can see that during the first 5 seconds, this object moved from a position of 0 to a position of 25. They must have moved in the positive direction. The other thing we talked about is what it means for the line to be flat like this, right? In this case, for the next 5 seconds, the object is staying at this position of 25 meters. So that means it's staying still. A flat line on a position time graph means it's staying still. Now, the next few things I want you to be able to understand is how do we figure out how fast an object is moving when we look at a position time graph? So I'll give you a couple of examples here. So first of all, how far has the object moved from time equals 0 to time equals 3? And then what is the object's velocity from time equals 0 to time equals 3? So we can look at this position time graph from 0, well, it's at a position of 0. And then at time equals 3, it's at a position of 15. So I might write some of those things down. And again, I highly recommend, kind of looking at these things and writing down your variables. So I know that my final position, sorry if this takes me a while, if you want to speed through the video really quickly while I take forever to write in these variables. But my final position, using just these time points of 3 and 0, I know that my final position was 15 meters. I know that my initial position was 0. And then I know the time that passed by was 3. So again, sorry if this is taking me forever to write this down. Okay, not the best handwriting for my doodling. All right, but basically I have all the numbers I need for this equation right here. So I'm going to plug those numbers in, and to find out how fast I was going, I would do 15 minus 0 divided by 3. It's a minus sign, make that a little bit clearer. Okay, divided by 3. All right, obviously 15 minus 0 is 15. 15 divided by 3 would be 5. And so this is a velocity, right? I want to know how fast it's going. So it's going 5 meters per second. And that's another thing. Conceptually, I hope that makes sense. When you look at this graph, you can see that every second it's increasing by 5. And that's what this velocity is telling you, is that for every second, it's going up by 5. So the velocity is 5 meters per second. All right, and then the last thing I'll just try to draw really quickly is a velocity time graph. So if I were going to draw a graph to kind of show velocity over time, well, I know for the first 5 seconds, so let's say this is like the 5 second mark here. For the first 5 seconds, it's traveling at 5 meters per second. So the line would be perfectly flat for the first 5 seconds. So for the first 5 seconds, my velocity is 5. Right? For the first 5 seconds, my velocity is constant. It's moving in a nice straight line. But then all of a sudden, my velocity drops to 0. So it kind of goes like this. It kind of just goes like bang and then bang. Now it's just moving across at 0. So for the first 5 seconds, the velocity is 5. And then for the next 5 seconds, my velocity is 0. So that's what the velocity versus time graph would look like. So this is velocity, and this is time. Okay. So that's how you can try to figure out the velocity of an object by looking at the position time graph. And then that's how you would make a velocity time graph based on the information you were given in a position time graph. If that's a little bit complicated, I'm glad to ask, or I'll be glad to answer any questions that you have in class. But this is a more advanced topic, a more advanced interpretation, and Again, this is for students that are really trying to get an A on this learning objective. But if that's you, I really appreciate you watching the video and shooting for that A. All right, good luck.